Hello everyone. The focus of this presentation is to make you understand about the classification of 8051 microcontrollers instruction set. And the presentation has been prepared by myself, Aarti Bokhade, along with my colleague Shekhjar Shah, and we both are the lecturers at Government Polytechnic Gandhinagar. These are the main objectives for the session. First, before beginning with the instruction set itself and its classification, one has to understand the various registers of 8051 microcontroller. So our first job is to highlight the various registers of 8051 microcontroller. Also, we have planned to discuss their functions. So whether it is general purpose registers or SFR, special function register, we would be discussing their functions also. And once this is done, we will classify the 8051 instruction set. So here if you see this diagram closely, it shows the various registers of 8051. So we start from the top. Let me highlight. Something what we denote by A is known as accumulator. Now accumulator is an 8-bit register which is responsible for doing or arithmetical, logical or general purpose operation. The same is with B register. B register is also an 8-bit register which is also used for general purpose data handling. Apart from that, we have the various general purpose registers starting from R0 to R7. Now these R0 to R7 registers, these 8 registers are allotted in register banks of 8051. Now you might be knowing that there are 4 register banks inside 8051, namely bank 0, bank 1, bank 2 and bank 3. And every bank has got its own R0 to R7. But the fact remains true is at a time out of all the banks, only one bank will be active. Now how do we select the bank? Whether we want to work with bank 0, we want to work with bank 1, bank 2 or bank 3. That selection is there with PSW. That PSW is known as program status word, which I'll show you later. So right from A register, B register, they are 8-bit registers and they are used for general purpose operations. Apart from that, you have R0, R1, R2, R3, R4, R5, R6 and R7. They are also 8-bit registers and they are also used for holding the general purpose data. But the only thing what differs is R0 to R7, they have been allotted their respective banks. Bank 0, Bank 1, Bank 2 and Bank 3. And these banks are nothing but the part of internal memory location. So internal data memory which range from 00 hex to 07 hex, that has been given to bank 0. Internal data memory location ranging from 08 to 0fx is allotted for bank 1. 10 hex to 17 hex has been allotted to bank 2 and bank 3 starts from 18 hex to 1f hex. So every bank has got its own R0 to R7, but at a time only one bank remains active. Now how many 16-bit registers we have inside 8051? So there are two 16-bit registers, namely DPTR and program counter. So here is program counter and next to that you have DPTR, which is further divided into two 8-bit registers, namely DPH. DPH is higher 8 bits of DPTR and DPL, that is lower 8 bits of DPTR. So it is all up to you. If you want a DPTR to be used as whole 16-bit register, you can make use of DPTR alone. If you want to bifurcate DPTR into two 8-bit registers, you can bifurcate DPTR into DPH and DPL. Now, altogether, if you see this diagram, you'll be able to see that there are two 16-bit registers, namely program counter and DPTR. And fundamentally, the various 8-bit registers are A register, B register, and R0 to R7. So this shows the general purpose registers of 8051. Now, let us talk about the various special function registers of 8051. So, the various special function registers for 8051 timing operation and counting operations are T-mode register, T-con register, TS0, TL0, TH1 and TL1. So all these registers are used for timing operations, counting operations. So that is why they are known as timer control registers. Apart from that, for the interrupts, you have IP register. Here it is, IE register. These two registers are used for interrupt programming. For the serial data communication, the various SFRs are SCON, serial buffer register, and PCON register, that is power control register. Beside that, as I told you, you have 4 ports, port 0, port 1, port 2 and port 3, which are also used for data handling. Now, this is the PSW of 8051. Very importantly, what you can see is PSW, program status word, contains all the flags: carry flag, auxiliary carry flag, user flag 0, RS1, RS0. These are the register bank selection bit. As I told you, there are 4 register banks. The selection of those 4 register banks can be done making use of RS0 and RS1. You have overflow flag and you have parity flag. And altogether, when you combine these 8 bits, this becomes program status word of 8051. Now, once the list of registers has been brought into your consideration, let us classify the instruction set of 8051. So, 8051 instruction set has been mainly divided into following groups: data transfer instruction, arithmetic instruction, logical instruction, bit control instruction or bit oriented instruction, and the last is branching instruction. So before beginning with all the instruction sets in detail, let us understand what do you mean by instruction. So in computer terminology, instruction is nothing but a combination of opcode and operand. So every instruction we talk about has got 2 important parts. One is opcode, which is also known as operational code, and the operand. Now let us understand what do you mean by opcode and what do you mean by operand. When I want to define opcode simply is the type of operation to be performed. Let us say add. If we want to add 2 registers content, we write add. So add becomes the opcode, the type of operation that we want to do, right? And the operands are nothing but the operations where we are performing the operations. Operands are the source or destination of the data. If you see here, the operands are nothing but the source and destination which carry data. So as an operand, it may be data value itself, it may be CPU register, it may be any memory location, or it may be any IO port also. So here if you can see, I have written an example. When you say move A comma B, move is the type of operation you want to do. So what type of operation you want to perform is, you want to transfer the data from B register to A register. So here this B register behaves as the source and A register behaves as the destination. So the meaning is, whenever you talk about the instruction, instruction has got two important parts. Opcode, that is the operation to be performed. Operands, they are the variables which carry data within them. It may be data explicitly within the instruction. It may be any of the CPU register. It may be memory location. It may be IO port. So with this, we are finishing the classification of instructions of 8051. In the next coming lectures, we'll be talking about the instruction set in details along with their suitable example. Thank you so much.